All right, so what we're going to do is I am going to work a couple problems with you. So we've been dealing with stoichiometry the last few days in lecture, and so what I want to do is talk about stoichiometry problem that deals with limit reagents, but it also, instead of just going on to solve for how much mass a product is produced, we're going to talk about how we determine the amount of excess that is remaining in the solution after the reaction is complete. So we're going to look at a reaction that involves hydrochloric acid reacting with sodium carbonate. Now, this is a double replacement reaction. We'll discuss double replacement reactions in the future, but for now, for simplicity, we're just going to give you the balanced equation here. So it's going to form carbonic acid plus NaCl. And so these are all aqueous solutions here in the end. And so what's important about this is again, we're going to determine the excess of the reagent that's left over. All right. So now in our first example, we're going to look at, so what I'm going to do is just give you some basic information. All right. I'm going to give us, I'm going to put in 1.00 moles of HCl. And then we're going to put in also 0.500 moles of sodium carbonate. Keep in mind that I am providing you the moles here. You could be provided volume and molarity, and from those two you can calculate the moles if need be. So, but in this case, we're kind of skip that step, and so we're just going to focus right in on what we have. All right. Now, since we have two different moles, what we're going to do is we're going to figure out the limit reagent for this particular solution. All right. So now, again, you have your have, and then we're going to do our need. So this is something that's going to play it. Now, again, we got to understand why is it that we're going to do this? How do we know to do this? Well, keep in mind that you're given two different moles for HCl and sodium carbonate. We don't know which one's going to have excess at this moment in time. All right, so what we need to do is we need to figure out, is there a limiting reactant in this reaction? So we have 1 mole of HCl, and then we have 0.5 moles of this sodium carbonate. All right, so what we're going to do is we're going to take this over, we're going to use the mole ratio to figure out how many moles of sodium carbonate we need, and then how many moles of HCl we're going to need. So we're going to use, again, we're going to use the mole ratio here. So for this HCl to sodium carbonate, it is a 1 to 2, so 1 mole of sodium carbonate to 2 moles of HCl. Now that gives you, so just taking that, divide that by 2, you end up with 0.5 moles of sodium carbonate. We're going to do the same thing with the HCl here, so we're starting off with 0.5 moles of the sodium carbonate, and we're just going to flip the ratio here. It's a 2 to 1, so 2 moles of HCl for every 1 mole of sodium carbonate. All right, so what that ends up giving you is 1 mole of HCl. All right, now, so let's figure out if we have a limit reagent here. So what we see is that we have 1 mole of HCl. What we need is 1 mole of HCl. So we have enough HCl here. And then looking at the sodium carbonate, we have 0.5 moles of sodium carbonate, and we need 0.5. So based off of what we're given in the beginning here, we don't have anything in excess. We're not going to run out of anything. We have everything we need. So therefore, there is no limiting reagent for this specific example, and there's no excess that's remaining because we have exactly how much we need. So now let's take this back to the beginning here, and let's give a different value. Okay, so now let's say that instead of we have 1.5 moles, we're going 1 mole. We're going to actually have, I said that all mixed up here. So we had 1 mole to begin with. This time we're going to have 1.50 moles of HCl. All right, so that's going to change this problem a little bit. So we're not going to change this value. We're going to keep it the same. All right, so now we have 1.5. So we're just going to go back through the process here, and we're going to recalculate how much we need. So now in this example here, So what we're gonna do is, we notice that 1.5 divided by 2 is gonna give me 0.750 moles of the sodium carbonate. Now this still stays the same because we did not change the amount of sodium carbonate from what we have in the beginning. We did change the moles of HCl. Now as we change this, so what we see here is that we have 0.5 moles of sodium carbonate. We're gonna need 0.750 moles of sodium carbonate. What does that tell me now? That tells me now that my sodium carbonate is gonna be the limiting reactant, because we're gonna run out of it first. All right, so this is your limiting reactant. What we do know is that since we know that limiting reactant is that we're gonna have excess HCl left over. The question is how much excess is gonna be left over. Now, based off this reaction, we only need 1 mole of HCl. We have 1.5 moles, so the excess HCl that will remain will be based off of the fact of just take the 1.50 moles that you have, we're going to subtract it from what we need, which is 1, and that leaves you with 0.500 moles of HCl. And so this amount of HCl will be in excess. That's how much will be left over from the reaction, because it does not go to completion due to the fact that we have a limiting reactant. Remember the first example we did, we had equal moles, so therefore there was no limiting reactant. But in this example, we run out of the sodium carbonate, so that means we're going to have excess HCl. So when you see those examples that say excess blah blah blah, that means that you're going to have some amount remaining, and this is how we go about determining the excess that is remaining in the overall reaction. So as you do these limiting reactant problems, it should be a thing you should practice and try to figure out, how much excess is going to be left over for that specific compound that is more than what you need. So, all right, that's it for now. If you have any questions, just shoot me an email. Thanks.